All right, so you plug in. That's always your first step because you never know what's going to happen. So you plug in, you get negative 3 plus 4 minus 1 over negative 3 plus 3. That's given us 1 minus 1, so 0 over 0. And so we know with the game, we got to try to factor, and then we have to cancel. And the cancel step is going to be x going to negative 3. So that means we want to try to cancel out x, the arrow becomes minus sign, negative 3, x plus 3. All right, so we want to cancel out x plus 3. So we have the x plus 3 in the denominator. We don't have the x plus 3 in the numerator. So we look at the numerator and it's like, well, how am I going to factor that numerator? But what we notice is that we have a square root. And whenever we have a square root, we think about multiplying by the conjugate. And the reason why we think about that is because when we have a conjugate times a conjugate, the radical sign disappears and we will just have the first two multiplied together and the last two multiplied together. Okay, so the way that we're going to be able to potentially successfully cancel out x plus 3 is by using the multiplication by the conjugate. All right, so let's see what happens when we do that. So we have x going to negative 3, square root x plus 4 minus 1 over x plus 3. We like the fact that we have an x plus 3 here because that's what we're trying to cancel, but we don't like the square root, so we multiply by the conjugate of the square root. So this is a minus, so we'll multiply by the plus 1 of that. Okay, so now when we look at this, again, the denominator is perfectly fine because the denominator, we have that x plus 3 factor. So we are not going to touch the denominator because we like the fact that we have the x plus 3 in there. But the numerator we are going to work with because the numerator we are not happy about the fact that we have all this square root mess in there. Okay, so the thing with the numerator is that you have a conjugate times a conjugate because the only difference is this negative to positive. So you can multiply the first two together and the last two together because the outer and the inner will cancel. Now, if you look at the first two, you have a square root times a square root. And when you have two of the same square roots, they're going to cancel and just give you x plus 4. And you don't need a parenthesis around that. So that first two multiplied together just gives us x plus 4. The last two multiplied together, we will have a negative times a positive, so that gives us a negative 1. And we still have the x's in this expression, so we still have the limit as x goes to negative 3. All right, so then we try to simplify the numerator, and when we simplify, we have 4 plus 1, so that gives us positive 3 over x plus 3 times square root of x plus 4 plus 1. Now, that is exactly where we want to be because we want to cancel out this x plus 3, and we now have an x plus 3 in the numerator and the denominator. So we very happily cancel out those x plus 3's. We're left with 1 in the numerator. And then we have the limit as x goes to negative 3 of 1 over the square root of x plus 4 plus 1. Now, we're not quite home free because the last step is always to plug in. So when I plug in, I lose my x, so I lose my limit notation, and I get negative 3 plus 4 plus 1. So that's going to be the square root of 1, which is 1, plus 1, so we get 1/2 as our final limit.